here we are. This is a test live stream. I didn't know how this worked, so there might be a bit of rubbish at the start, but let's get started straight away. So Chat GPT gave me 100 differentiation questions. You can see them all on the screen right now. I'm just moving the camera forward a wee bit. We'll get started. So I've put in the course spec for higher maths and advanced higher maths, and it gave me these 100 problems to do. Now I'm going to live stream right now and see how this goes, just to get an idea of how this works, but also works. I'll re-edit this later on if the footage is any good. So let's get started with this and see how it goes.
Clelland Maths is sponsored by Lecky, the educational publisher for Scotland. They offer viewers of this channel a massive 30% discount. Just use the discount code ClellandMaths at leckyscotland.co.uk. The practice question books go all the way from level 3 to advanced higher and include National 3, 4 and 5 apps as well, so you can get any book you need for your studies. These are an excellent resource with questions on every topic and contain work solutions so you can see how the marks are awarded. As you go through the book, the questions get increasingly difficult, so by the time you finish the book, you'll be ready for your exams. Usually £9.99, just use the discount code ClellandMaths to get 30% off that. Link down below.
Basic differentiation, algebraic functions. So I'm just going to start differentiating these. This is just using the power rule. Differentiate 3x squared. So dy by dx. I'll probably need more space in a minute. 2 times 3 is 6, and then x. Right, let's do question 2 at the side. 5x cubed, so dy by dx. 3 5s is 15, and then we've got x. And take away 1 squared. Okay, nice and easy to start with. Question 3. dy by dx. 4 7s is 28x. 4 minus 1 is 3, so 3. And then 2 3s is 6, x squared. That's working fine for me. Let's try number 4. dy by dx again. 5 4s is 20x4. 3 2s is 6x. And then plus 6. That's working good. Let's move on to number 5. dy by dx. So we've got 8 6s is 48, x, 6 minus 1 is 5, 3 3s is 9, x squared, and x is just 1 plus 1. Okay, number 6. Oh, dy by dx, 7 9s is 63x6, 4x cubed, so minus 4x cubed, 2 5s is 10, and then I've got an x. Number 7, oh, 1 over x. Well, I'm going to change that to x to the minus 1. So dy by dx is minus 1 x to the minus 2. Tidy that up. That's minus 1 over x squared. I'm happy with that. There's number 8. 2 over x squared plus 3 over x cubed. So number 8, 2 over x squared is 2x to the minus 2 plus 3x to the minus 3. So dy by dx is minus 4x to the minus 3 minus 9x to the minus 4. Or you could leave it as positive powers, but I'm not going to bother. I've got 100 of these to do. So number 9. dy by dx, what have we got? Minus 10x. So it's a minus, then minus 3. 7 4s minus 28x. Minus 4 minus 1's minus 5. Good. Number 10. Y equals 6x to the half, so dy by dx. A half times 6 is 3x. A half minus 1's minus a half. And then 4 3s is 12 divided by 2 is 6. So minus 6x minus 3 halves becomes minus 5 halves. And we're done there for the first section. The first 10 are done. Right, on the second section. Well, it looks like trigonometric functions here. They're just basic ones, although it has added a bit of product rule straight away. So if you're doing higher maths, I think you'll find number 18 and 19 and 20 perhaps a little bit too hard. But let's try. Number 11, sine goes to cos. So we've got cos x. Number 12, cos goes to minus sine. So we've got minus sine x. Number 13, chain rule I think here, to dy by dx. I've got 2 cos and then 2x. 14, dy by dx minus 3 sine 3x. So you differentiate when you differentiate in a function. What have we got? 15. Okay, 15. Sine becomes cos, so I'll write cos 4x squared. Now I need to differentiate 4x squared, that's 8x. So I'm happy with that. 16, cos becomes minus sine, x squared plus 2x. But then I need to differentiate by x squared plus 2x. So that's going to be 2x plus 2. I'm going to need to times by 2x plus 2. So writing all that out, I'll get minus 2x plus 2 sine x squared plus 2x. And you could take 2 out as a common factor if you really wanted to there. Let's add a page and move on to question 17 swiftly. We've got dy by dx, 3, actually no, I'm going to just do it straight away. 3 5s is 15 cos 5x. 4 2s is 8. A minus cos, well, cos goes to minus sine, so minus cos goes to plus sine. So plus 8 sine 2x. I feel like Chat GPT is trying to trick me here. Right, number 18, that's the product rule. Now, if you're doing advanced higher maths, this will be suitable for you. So I'll let u equal 5x and v equals sine x. And u dash when n equal 5 and v dash was cos x. And remember your rule is vu dash plus uv dash. So just putting all that together, I've got sine x times 5, 5 sine x. And then 5x times cos x, 5x cos x. So I'm happy with that, I think. Let's look at number 19. 19 is 7x cos 2x. Let me write that down, 7x cos of 2x. So that'll be my u, that'll be my v. U dash is 7, v dash is minus 2 sine 2x. So it's vu dash plus uv dash. So what does that give me? Cos 2x times 7, 7 cos 2x then. And then u is 7x and v dash is 2 sine 2x, so minus 14 sine 2x. Quite happy with that. Number 20, y equals x squared over sine x. So let's have a look at that one. Y equals x squared over sine x. If you've just joined us, hello. This is a test live stream for differentiation. So I've done, Chat GPT gave me 100 questions. I'm actually doing a bit advanced higher maths question here, but stick with me if you're doing higher maths. We've got a mixture of both. So we've got u here and v there, and u dash is 2x, and v dash is cos x. And the rule for the quotient rule is vu dash minus uv dash all over v squared. Right, so how does that work? Well, v is sine x and u dash is 2, so I've got times them by 2, minus u, which is x squared, right? Okay, v dash is cos x, all over v squared, which is sine squared x. Now you could tidy that up, but I'm not going to bother. I think I'm happy with that. Let's move on to what Chat GPT gave us next. Doing 100 differentiation questions, and they're now doing the chain rule for composite functions. Again, if you're doing advanced higher maths, then this will be relevant and that will be relevant, and so will that. But the rest will be higher maths, really. So 21. The y by dx. I take the 4 down to the front. I've got 3x squared plus 5 hanging around. And then I take 1 away for the power of 3. But now I need to times by the bit inside the bracket differentiated. So what have I got? 3x squared plus 5. So I need to times by 6x. Tidy that up then. 4 6s is 12x. 3x squared plus 5 cubed. Happy with that. Okay, next one. 22. The y by dx. 5. 2x plus 1. 4 times, put a dot for times, quite a common thing to do. And what we got? 2x plus 1 is 2. So that just gives me 10, 2x plus 1 to the 4. Happy with that one? Let's move on to 23. Oh, that's a big one. Right, dy by dx. What we got? 6. Then the whole thing, 5x cubed minus 7x squared plus x, then a 5. And now I need to times by this whole thing differentiated. Right, so times, I'll put a dot, bracket, 3 5s is 15x squared. I think I've lost a sign. Oh yeah, there's a 2 there. 7 2s is 14x, then plus 1. There we are. So 6, nasty function, times, I've not got space, I'll just put it underneath, but it should be next to each other, nasty function. I'm not going to try and do anything else with that one. Right, we're on 24. X squared plus 3x plus 1 equals 7. I'll just do it here. The y by dx. 7. X squared plus 3x plus 1. And then we've got 6. Now I need to times by x squared plus 3x plus 1 differentiated, which gives me 2x plus 3. Tidy that up slightly. 7, 2x plus 3, x squared plus 3x plus 1 equals 6. Right, 25. I'm just going to copy these down to the next page so I don't need to keep coming back up actually. So there we are there. And we're on 25. So 4x plus 5, is that a half? Yeah, it's a half. Y equals 4x plus 5 to the half. The y by dx, this is 25. Stupid calculator, go away. 25. No, I can't even write. Oh, I'm in black, that's why. Bear with me. Usually edit all this nonsense out. So, half 4x plus 5 minus a half, and then we need to times by 4. 4x plus 5 goes to 4. So what does that give me? 4 times a half is 2. 4x plus 5 minus a half. Now we could make that like a positive power by putting it over 4x plus 5 to the half, but let's not bother the day and go to 26. Oh, sine. Okay, the y by dx, start of the exam paper tells me is cos. So I'm going to leave a big space at the front here. 3x squared plus 2x. And now I need to differentiate 3x squared plus 2x. Well, 2 3s is 6x. And 2x becomes 2, all in brackets, and I'm done. 27. Cos goes to sine, well, minus sine really. So we've got minus sine 5x squared plus 7x times, differentiate 5x squared plus 7x. What's that? 10x plus 7. I'm quite happy with that. Just tidy it up. Minus 10x plus 7 sine 5x squared plus 7x. That's good enough for me. 28. Wonder if I'll get through all 100 today or if I'll get tired. Y equals 3 e to the power of 3x squared minus 4x. 3x squared minus 4x, yeah. Okay, if you're doing advanced higher maths, you'll realise that e becomes e. It's one function where you differentiate it back to what you started with. So I just write e again, 3x squared minus 4x. But now I need to differentiate the 3x squared minus 4x. So what does that give me? 6x minus 4, and that gives me 6x minus 4 e 3x squared minus 4x. So I'm still stopped quite clear for a minute because I've noticed I've got a chat going on. So JT says, hi Mr. Clelland, thanks for help with the A and the higher last year. Any plans for advanced higher lessons? I have at least 10 others who I think would benefit this. Good question. Right, so yes, I'm on the advanced higher maths. I've got quite a bit coming up for that. You can imagine it takes a hell of a lot of time to film, but I am starting today. I'm doing the product rule and the quotient rule. I'm going to go through the whole differentiation. I'm going to try and make it as concise as I possibly can instead of making it hours upon hours upon hours of content, but everything concise to get through the course for you. So yes, to answer your question, it is coming. Frankie Tanky, I got an A in higher maths thanks to you. Do you think you will do advanced higher maths? I could just answer that, Frankie. So there you go. But if you keep watching now, you will see plenty of advanced higher maths questions coming up because I asked Chat GPT for 100 differentiation questions based on higher and advanced higher getting increasingly difficult. We're on one right now. We're going to go to 29. So 29 says log 4x cubed plus 7x squared. So we've got y equals log 4x cubed plus 7x squared. Now, I'll need to add a page, of course, but you should know that a log differentiates to 1 over the function. So the y by dx to start with is 1 over 4x cubed plus 7x squared. But then because of the chain rule, I need to differentiate 4x cubed plus 7x squared. 3 fours is 12x, 7 twos is 14. 12x squared, sorry, plus 14x. Tidy that up, we get 12x squared plus 14x all over 4x cubed plus 7x squared. Factorise the top, so 2x is a common factor, 3x plus 7 I think. Bottom factorises to x is a common factor, 4x squared plus 7x. God, x squared, stupid. Right, let me fix that. So that's going to be 4x plus 7. Yeah, that's it. And now I can cancel an x from top and bottom to leave 2, 3x plus 7 over x, 4x plus 7. Hope I've done that right. If not, let me know. Number 29 is done. Number 30, y equals sine log x. Let's try it. Number 30, sine of log x. Well, I know that sine goes to cos, so that's the cos of log x. Then I need to differentiate in a function, so I need to times by 1 over x. Tidy that up, I get cos of log x over x, and that's fine. Let's move on. Product rule. So this is purely advanced higher maths if you're watching right now. No one's on the free here, but there you go. So let's do this now. Product rule, remember, is vu dash plus uv dash, where your function to start with is a function of u and v, u of x and v of x, times together. So you do each one, you do your v, then your u dash plus your u, then your v dash. So looking at 31, my v is sine x, but my u dash is 2x, because I've differentiated it. Plus my u is x squared, and my v dash is cos x. So that's it there. Tidy that up slightly. I'll probably take x out as a common factor to get 2 sine x plus x cos x. That looks reasonable. 32. All right, here we go. Starting to put the chain rule in already. So my u is x cubed. U dash is 3x squared. My v is cos 2x. So my v dash is minus 2 sine 2x. So putting this together, we've got vu dash, which is 3x squared cos 2x, plus my uv dash, which is x cubed, well, minus 2x cubed, sine 2x. Pretty sure that's good. Suppose we could take out x squared as a common factor if you really wanted to. 3 cos 2x minus 2x sine 2x. I wouldn't bother expanding sine 2x because that's 2 sine x cos x. I'll just leave it there, I think. Simplification is the hardest bit, knowing when you're finished and when you're not. 2x plus 1 sine 3x. So u is 2x plus 1. U dash is just 2. V is sine 3x. So v dash is just 3 cos 3x. Yeah, pretty sure that's right. So vu dash 2 sine 3x. I'll just say dy by dx. Plus uv dash. Well, it's 2x plus 1 times 3. So 3 times 2x plus 1 times cos 3x. Done. 33 that was, so let's do 34. So 34 is 3x squared plus 4 cos 5x. 3x squared plus 4. U dash then must be 6x. V is cos 5x. So V dash is minus 5 sine 5x. Happy days. Right, so VU dash, I'll just say, I can't be bothered. Y dash, we'll say, I can't be bothered into y by dx every time, so we'll use Lagrange notation. Right, VU dash 6x, 5x. cos 5x, plus u v dash, well, minus 5, 3x squared plus 4 sine 5x. Done there. 35. Oh gosh, right, x cubed minus 2x squared sine x squared. Sine x squared, right? I think that's right. So u dash 3x squared minus 4x v dash cos x squared times 2x. Chain rule. Okay, vu dash, let's do that. 3x squared minus 4x. So good so far. And then u dash, well, vu dash, so it's sine x squared, plus u x cubed minus 2x squared times 2x, so 2x, x cubed minus 2x squared times cos x squared. Are we going to tidy this up? I suppose I better. Right, let's take out my common factors. In the first one, you've got x to get 3x minus 4 sine x squared. Second one, you've got another x, so 2x squared, x squared minus 2x cos of x squared. So 36 is this one here. So u is x4 minus 7x. U dash is 4x cubed minus 7. Fantastic. V is cos 2x plus 1. And we've got v dash is minus sine 2x plus 1 times 2 because of the chain rule. Yeah. Right, let's go. Vu dash. So y dash is equal to 4x cubed minus 7 cos 2x plus 1 plus u times v dash, which is minus 2 sine 2x plus 1. Hope you can see that there. Right, we'll tidy that up slightly, I suppose. 4x cubed minus 7 cos 2x plus 1 minus 2 x to the 4 minus 7x. I'll just put an x here. I was thinking x cubed minus 7 sine 2x plus 1. Done. 37. We have to differentiate that. So u is 5x squared minus 4x. U dash is 10x minus 4. And v, we're on 37, yep, log x. And v dash goes to 1 over x, I hope you know. So y dash is vu dash log x 10x minus 4 plus uv dash, which is 5x squared minus 4x times 1 over x. So that's 10x minus 4 log x plus, well, let's take x out as a common factor here. 5x minus 4 over x, because the x are going to cancel, which is nice and cool. 10x minus 4 log x plus 5x minus 4, and we're done there. Right, next one. What are we on? 38. 3x squared plus 5x sine x. So there's my u, and there's my v, and there's my u dash, which is 6x plus 5, and there's my v dash, which is cos x. New page. Right, any questions, feel free to shove it in the chat. Remember, we're here doing maths, higher maths, advanced higher maths. So we're at advanced higher maths stage for differentiation. Chat GPT provided us with 100 questions. Remember, this is a test stream, so it's not going to be perfect. I should really have overlays and all that jazz, but I'll get to that once I learn them. Right, so let's move on. Vu dash sine x times 6x plus 5 plus uv dash, which is 3x squared plus 5x times cos x. Oh no, doesn't look right at all. Let's try that again. VU dash I've done plus V dash, yeah, cos x. I think I just said it wrong. And we're done there. Right, 39. X squared plus 1 cos 2x squared. This is getting tricky, you know. X squared, can't even remember my brain. X squared plus 1 cos 2x squared. There we are. U dash is 2x. V dash is a chain. It's going to be, well, 2x squared differentiates to 4x, and then cos differentiates to sine. Well, minus sine, I almost missed it, 2x squared. There we are. So y dash is v times u dash, 2x cos 2x squared, plus u times v dash, so minus 4x x squared plus 1 sine 2x squared. That looks all right to me, doesn't it? Yeah? Well, I suppose we could take x out as a common factor, but it's not really going to make it nicer because you're going to get cos 2x squared minus 4 with an x outside. Don't really think anyone cares about that. So I'm just going to leave it there. Number 40. Differentiate x squared e to the 3x. E to the 3x or e to the x? 3x. Okay, u dash is 2x, v dash is e to the 3x, but times by 3. So we've got vu dash again. So we've got 2x e to the 3x plus vu dash plus uv dash, which is x squared times 3 e to the 3x. And in this case, I will take a common factor out because e to the 2x is a nice common factor, and so is x, leaving just 2 plus 3x in the bracket, or 3x plus 2. So that's like nice. 41 is the quotient rule. Now, the quotient rule is, in case you remember, I've got two functions. F of x is some function in u over some function in v. F dash x then is vu dash minus uv dash all over v squared in Lagrange notation. So we'll have to label one of our functions u and v, find the differentials, and plug it into this by substitution. 41. So u is x squared, which means u dash is 2x. V is sine x, which means v dash is cos x. So f dash x is vu dash, which is 2x sine x, minus uv dash, which is x squared, what am I doing? X squared cos x, all over v squared, and v is sine x, so it's sine squared x. Now we could try and tidy that up, so let's see what happens. Split it up into two separate fractions perhaps. So the first fraction is going to give me sine x over sine squared x, so that's going to be 2x over sine x, minus x squared cos over sine squared x. Well, cos divided by sine is 1 over tan or cotan. So I could write cot x over sine x. I think that would work. Cos divided by sine is cot, and I've still got a sine left on the bottom. That's quite nice actually. So I get 2x minus x squared, which is x, 2 minus x cot x, all over sine x. I think I'll leave it like that. And 42 says x cubed over cos 2x so there's my u and v. So my u dash is 3x squared, and my v dash is minus 2 sine 2x. So now what we need to do, differentiate this. So we've got y dash is vu dash, so 3x squared cos 2x, minus uv dash, well, minus times a minus is a plus, 2x cubed sine 2x, all over cos of 2x squared. Cos squared 2x or cos of 2x all squared, whatever you prefer. I'll take some common factors out. So we've got x squared as a common factor on the top to give 3 cos 2x plus 2x sine 2x all over cos 2x squared. Now you could split this up into separate fractions as well if you felt that was simpler. So you've got your x squared, the cos 2x and the cos 2x we can simplify to 1 over cos 2x, and the sine 2x and the cos 2x squared would simplify to tan 2x over cos 2x. So you could get a tan coming out if you wanted to, but because I've got lots of these to do, I think I'm going to leave that one there. Number 43, 4x over x squared plus 1. Is it 4x? Yeah. Going on my way for trig functions for a bit. So u and v, u dash is 4, v dash is 2x. So y dash is vu dash x squared plus 1 times 4 minus uv dash 4x times 2x all over x squared plus 1 all squared. Okay, so what happens when we do that one? Well, that gives me 4x squared plus 1 minus 8x squared, x squared plus 1 again, all squared. Let's expand that top bracket then. You've got 4x squared from here, minus the 8x squared would give me minus 4x squared. Take out plus 4 over x squared plus 1 all squared. 4 is a common factor on the top to get x squared plus 1 over x squared plus 1 all squared. Very nice. So that gives me 4 over x squared plus 1. And we're done there. I like that one. Okay, number 44. X squared minus 1 over x squared plus 2. Y equals x squared minus 1 over x squared plus 2. U and v. U dash is 2x. V dash is also, that's an x by the way, 2x. So y dash is v times u dash minus u times v dash over v all squared. I can see the 2x is a common factor already on the top to give me x squared plus 2, and then minus x squared, and a minus times a minus is a plus 1, x squared plus 2 all squared. So that's going to give me 2x times, well, x squares disappear, 3 over x squared plus 2 all squared. So that's just 6x, x squared plus 2 all squared, and we're done there. 45, u is x cubed minus 2x. U dash is then therefore 3x squared minus 2. And then v is x squared plus 1. So v dash is 2x. And now we can just differentiate it again. So y dash is vu dash minus u times v dash over v squared. Thanks very much, Tiger. Hopefully you find it useful. This is a test live stream, seeing if live streaming is going to work for me or not. So I've got Chat GPT to give me 100 differentiation questions. It's given me higher, mostly advanced higher maths, so have fun with that. Right, let me try and finish this one before I make a mistake. X squared plus 1, 3x squared minus 2. Oh God, what we got? Just 2x, 3x cubed minus 2x over x squared plus 1, all squared. So I really want to simplify this. With double brackets is going to give me an x to the 4, so they're not going to get anything nicer on the top. I could take x out as a common factor from the second term and get 2x squared. And nothing much else. So I'm going to add a page, but I'll fix it now. But I would say that you've got x squared plus 1, 3x squared minus 2, minus 2x squared, x squared minus 2 again, over x squared plus 1 all squared. And I'm sure you could play around with it and get further with that, but that seems reasonable. So I'm just going to stop there. Number 46. Right, so we can see it up here. U is x squared plus 2x plus 1, and v is sine x. So now I need either my u dash, which is 2x plus 2, and my v dash, which is cos x. Hopefully this will be a nice one. So my y dash is v u dash, 2x plus 2, times sine x, minus u, make sure I get my brackets, times v dash, over v squared. So far so good. I will try and tidy this one up. 2x plus 1 sine x minus, here we go, x plus 1, x plus 1. That's x plus 1 squared cos x. X squared plus 2x plus 1. Yeah, nice. Sine squared x. So now I can take x plus 1 out as a common factor on the top as well. So that will give me 2 sine x here minus x plus 1 cos x here. That's quite nice. Not much else you can do. Is there 2 sine x minus x cos x plus 1 cos x? I'm tempted just to leave it there, I think. Okay, next one. 47, x to the 4, 5x squared over cos x. X to the 4 plus 5x squared over cos x. I'll be happy to finish the quotient rule in a minute, which will move on to the implicit differentiation. So u and v gives me u dash is 4x cubed plus 10x, and v dash is minus sine x. So let's do y dash. V times u dash, 4x cubed plus 10x, times cos x, minus v vu dash minus uv dash, x4, 5x squared, minus sine x over cos squared x. So we can tidy that up a wee bit. Take x out as a common factor to start with, and a 2 to give me 4x squared plus 4. 2 4s is 4, is it? Right, right. It's a 2 2s is 4 plus 5. And cos x. Now minus times a minus is a plus. I can take an x squared out. I can take x squared plus 5 sine x cos squared x. So you could say, I suppose, that x is a factor of both of these things, and then you would have It's not going to get much simpler because you're going to have still have x cubes over here over the right hand side. You could split it into separate fractions. I think I'll just leave that one at that. Most of the time in advanced higher maths, by the way, these are question 1, and you're getting a mark for the first term, a mark for the last term. And simplification is usually quite easy, or it's usually okay. 48 x squared over e to the x. I quite like the look of that one. So we've got y equals x squared over e to the x for 48. So that's u and v. So u dash is 2x and v dash is e to the x. So y dash is v times u dash minus u times v dash over v squared. Now e to the x squared is e to the 2x. So that gives me e to the x as a common factor on the top and an x, of course. 2 minus x over e to the 2x. And then we can cancel on e to the x. So e to the 2x, remember, is e to the x times e to the x. So that gives me x, 2 minus x over e to the x. And we're done there for 48. Sin x over x squared for 49. So u is sin x, u dash is cos x, and then we're on v. V is x squared, and v dash is 2x. So y dash is v u dash x squared cos x minus u v dash 2x sin x over v squared, which is x squared squared, which is x4. X is a common factor, of course, so I can take x out. X cos x minus 2 sin x all over x cubed. I've just divided everything by x, essentially. I think I'll leave that one there. Number 50. U is e to the x, u dash is e to the x, v is x plus 1, and v dash is just 1. So that's going to give me v u dash e to the x, x plus 1, minus u v dash, which is e to the x, over x plus 1 squared. E to the x plus 1 minus 1, common factor there. So that's just x e to the x over x plus 1 squared, which is quite elegant as well. We're on implicit differentiation. Remember, if you've just joined us, Chat GPT gave us 100 differentiation questions to solve. It started with higher maths, it's now quickly got to advanced higher maths, it's got increasingly difficult, and I'm trying my best to get through all of them today, but we'll see how we go. So this is more of a test stream, so if you are joining us and you are usually a subscriber to this channel, I'm testing the stream out, see how it works, see how to put it all together for later. So perhaps during the year I can maybe do more live streams where I jump into a specific topic that my viewers are maybe interested in. But let's jump into implicit differentiation here. So dy by dx for x squared plus y squared plus 1. Implicit means you differentiate it as it is sitting there. You don't make y the subject. So for 51, x squared just differentiates to 2x. And then y squared, because of a chain rule, I do the y by dx times 2y. So you always just differentiate it as if it says x, 2y. But then if it's a y, it changes to dy by dx. And now the 1 becomes 0. And usually the question wants to find dy by dx, so I need to make dy by dx a subject, which in this case is just minus 2x over 2y, or x over y, or minus x over y. And we're done there. 52. We get 2x. Now we get the product rule coming in. So I'm going to use that is my u and that's my v. So plus vu dash, so times by 2, plus 2x, and then v dash is dy by dx. And then y squared is also 2y dy by dx, and 0, 0. So what I usually do at this stage is I just take my dy by dx and take the common factor of that to get 2x plus 2y on the left, and move everything else that isn't got a dy by dx to the right. So that's minus 2x minus 2y. and then just divide. The y by dx is minus 2x minus 2y over 2x plus 2y, which we can tidy up, of course. The y by dx for this, 3x squared. 3y cubed, 3y squared, the y by dx equals a chain. V is y, u dash is 3x, which becomes 3, plus u is 3x, and y is the y by dx for v dash. So even the y by dx is over the same side, so to move them up the left, so I've got 3y squared dy by dx minus 3x dy by dx equals 3y minus 3x squared. A lot of 3's there, so let's just get rid of them straight away. Take the y by dx as a common factor, and I'll have, if I take 3 of them, and I take 3 on the other side, the 3's will cancel. So we'll just have y squared minus x equals y minus x squared. So the y by dx is y minus x squared over y squared minus x. Y minus x squared. Yeah, happy with that. Let's move on to the next one, I think. Just going to move this down a little bit so I can see it. $54. X squared becomes 2x, y squared becomes 2y dy by dx. Now we've got 2xy, so that's v u dash 2y plus u v dash dy by dx equals 0, because 4 becomes nothing. The y by dx is the common factor, 2y plus 2x, and then the stuff that's not got y's and x's in it, minus 2x minus 2y, minus 2x minus 2y over 2x plus 2y. 2's cancelled to give minus x minus y over x plus y minus x plus y over x plus y. They cancel, that's just minus 1, isn't it? Is that right? Minus x minus y? Yeah, it's just minus 1. I'm sure I could have done that up here then. Yeah, you could have done the same thing there. Minus x plus y over x plus y. That's minus 1 as well. What was that, 52? Right, 55. X squared plus xy plus y squared equals 6. Two x plus vu dash y plus uv dash plus 2y, the y by dx, equals nothing. Not too bad there. So then we can take the y by dx as a common factor. X plus 2y equals, and then minus 2x minus y. So the y by dx minus 2x minus y over x plus 2y. I'll leave that one there. I think I could take it minus 1 as a common factor, I suppose, to get minus 2x plus y if you prefer, for x plus 2y. No, we don't need to do that. X squared becomes 2x. 3xy becomes v times u dash. So that's a y 3y plus u times v dash, which is dy by dx, plus 2y dy by dx equals 0. The y by dx, common factor of 3x plus 2y, equals minus 2x minus 3y. So dy by dx minus 2x minus 3y over 3x plus 2y. Or if you prefer, 2x plus 3y with a minus in front over 3x plus 2y. 57. Oh, we've got some sine and sine. That's nice. Sine x plus sine y equals 0. 57, sine becomes cos plus cos, but dy by dx equals 0. So that means that dy by dx is minus cos x over cos y. Quite nice. 58, e to the x plus e to the y equals 1. Well, e to the x differentiates to e to the x, e to the y differentiates to e to y, but that's dy by dx, 0. So we could say dy by dx is e to the x with a minus in front over e to the y. And we're done there. You can make that just in terms of x quite easily, by the way, because e to the y would be 1 minus e to the x. So you would get minus e to the x over 1 minus e to the x, if you preferred as well. 59, x sine y plus y cos x equals 1. Check that again. X sine y plus y cos x equals 1. So VU dash sine y times x is 1, plus u times v dash, sorry, the dy by dx, plus, and then uv dash again, so cos x dy by dx, plus uv dash minus sine x equals 0. So sine y plus x cos y dy by dx plus dy by dx cos x minus y sine x. Dy by dx is your common factor to give you x cos y plus cos x. So that's just for this bit and this bit. Moving the y sine x over, take away the sine y, divide y sine x minus sine y all over x cos y plus cos x. And we're done there. Number 60 coming up. X sine xy equals x plus y. Wow. Wow. Sine becomes cos. And then we need to differentiate the xy with respect to x. So that's a product inside the chain. Very nice. So VU dash, so we're going to times by V is y, U dash is x, plus U is x and V dash is dy by dx. So that's what xy differentiates to. Equals x is 1 and 1 y is dy by dx. So that gives me y cos xy plus x dy by dx cos xy equals 1 plus dy by dx. Moving everything over so that we've got dy by dx together, we would have y cos xy on this side minus 1 equals dy by dx minus x dy by dx cos xy. So now we need to, dy by dx is a common factor, 1 minus x cos xy is y cos xy minus 1. So and finally, dy by dx is y cos of xy minus 1 over 1 minus x cos of xy. And we're done there. Okay, and we're back. So Chat GPT gave us 100 differentiation questions from higher all the way to advanced higher, increasingly difficult, and we're on logarithmic differentiation. Now this is just a test stream, of course. This is to see how streaming works for me, and if it doesn't work for me, I will do regular lessons live on YouTube. But let's begin with 61. My gosh, this is difficult, but we've got y equals x to the power of x. Now, how logarithmic differentiation works is you take the log of both sides. So we're going to start with log y equals log of x to the power of x. I'm going to need to add a page. So log y equals x log x because of the rules of logs from higher maths. But now we can differentiate implicitly both sides. Log y becomes 1 over y dy by dx. And then the other side is a product rule. V times u dash, that's just log x, plus u times v dash, which is 1 over x. Well, that's nice, because that gives me 1 over y dy by dx is equal to log x plus 1 x over x. So dy by dx is simply y times the whole of log x plus 1. But we know what y is. It's x to the power of x. So that's just x to the power of x log x plus 1. And we're done there. Let's do number 2. It says x squared plus 1 cubed over x plus 2 squared. Let's just check that again. X squared plus 1 all cubed over x plus 2 all squared. Now, I'm not sure why Chat GPT wants me to do this by logarithmic differentiation, but since it's asking, I'll do log y. I would usually have just done the product rule, you see. Log x squared plus 1 cubed over x plus 2 squared. So I can separate that out into log x squared plus 1 cubed minus log x plus 2 squared. And then the rules of logs gives us that. Okay, we're back. So we've got that and we've done take away. So let's see what that's leaving us with. Log y equals 3 log x squared plus 1 minus 2 log x plus 2. So we can just differentiate that. 1 over y dy by dx. 3 over x squared plus 1 times chain rule 2x minus 2 over x plus 2 chain rule times 1. So that's the power of logarithmic differentiation. It avoids that quotient. 1 over y dy by dx equals 6x over x squared plus 1 minus 2 over x plus 2. So times them through by y. But remember, y was equal to this thing here. So we've got x squared plus 1 cubed over x plus 2 all squared times the whole of this function the new page. Well, I can cancel from the first fraction, so the y by dx. This one and this one cancels by 1, so I get times them together 6x x squared plus 1 squared over x plus 2 squared. Then times out the second one, I'll get minus 2 x plus 1 all cubed over x plus 2 all cubed. Common denominator is x plus 2 all cubed. So that means that this one is 6x x squared plus 1 all squared times x plus 2 minus 2x plus 1 all cubed. Now you could go ahead and expand the top, try and factorize it, see if you get anything nicer or neater. But x plus 1, I think I'll probably just leave that one there because otherwise I'll be here all day. So I'm just going to leave that one. But you get the idea, yeah? 62 is done, 63. At this stage, I am going to stop now my test live stream. I think I've got a good idea of how live streaming works. And one thing I have learned is no way in hell will I be doing 100 questions in a live stream ever again at this level of difficulty, because I think I'd be here, it's 3:26 now, I think it would be here another 2 hours at least to finish these. These are quite long-winded. Then you've got inverse trig, parametric, related rates of change. So it does get quite heavy. So yeah, I think I'm going to stop there. I think I've got a good idea how this works. I think I could fix a few things, make sure there's transitions for when I'm on a break, make sure there's messages for you, make sure the chat is working good. But hopefully, if you have stuck around for a little while, you've found some use in that. I'll be back soon. Take care, stay safe, and goodbye.